Okay, now the next SPSS lab that you'll be completing based on the content for this week is correlation and regression, both simple linear regression and multiple regression. Again, please make sure you use the correct data set that's been provided. I will be using, again, a data set that probably looks familiar to you from previous examples and from previous work, but is not the data set you will be using for this assignment. This assignment will incorporate some of the things you've already learned. So you're going to be doing things like when you have your data set, calculating the descriptive statistics. So for the sample, if you've got data like gender, race, ethnicity, you're going to run frequencies for that data about your sample. For your continuous variables, you're going to report means and standard deviations and ranges. So some of those key descriptive statistics, again, read the assignment for the specific variables you need to do that for. And then you're going to start with running a correlation. So remember, a correlation is simply what is the relationship between two variables. So not looking at any direction of the relationship, but just what is the relationship between two specific variables. So for example, in this data set, let's say I was interested, we have scores on a final exam for statistics. And we also have information on a student's IQ, GPA, their math a score of math anxiety. And let's say you just wanted to know what the relationship is between a student's GPA when they come into the course and their final grade. So after you've run all the descriptive statistics, frequencies, mean, standard deviations, we're going to start with a simple correlation. So to run a correlation, you're going to go to Analyze. You're going to go down to where it says Correlate. You're going to select bivariate. Bivariate just means two variables. So you're running a correlation essentially between two separate variables. You're going to see a box that looks like this. I'm going to go ahead and exit out of that. And again, let's say I wanted to know if GPA, let me reset this, if GPA was related to a student's score. So all you're doing is selecting the two variables. In this case, I'm going to show you how you can put more in there, but for our first example here, I'm just going to put those two variables. So this is going to tell me once I hit OK in just a second what the correlation is between GPA and final exam. One quick thing I want to show you is I always click this button, show only the lower triangle. It presents the correlation table in a much more meaningful way and much easier to digest. So make sure you select that. Then I'm going to hit OK. And what you see here is a simple correlation table between those two variables. In this case, you see grade point average here, and you see score on a final exam here and here. If I go here, GPA and score, and just connect the two, where it says Pearson correlation, this is the correlation, or R, statistic, 0.517. As a reminder, correlations are always going to range from -1, which represents a perfect negative correlation, through +1, which represents a perfect positive correlation. It's important to take note from your reading in the material that 0.517 represents what we consider maybe a moderate to strong relationship. It is a positive relationship. What does that mean? It means as one goes up, the other goes up. In this example, as somebody's GPA goes up, the score on their final exam goes up. So across the data set, those with higher GPAs are also going to have, in general, higher scores on the final exam. In terms of whether this statistic is significant, we look right here where it says the significance, two-tailed. Remember, we're looking for anything below 0.05. So if it's below 0.05, that's a p-value. That represents a statistically significant a factor statistic. In this case, it's well below that. So we say that this correlation of 0.517 between GPA and final exam is not only positive and moderate to strong, it's statistically significant. And here this N just means 112. There were 112 pieces of data, 112 people that had GPA and score on their final exam. Let's say I wanted to, so that's one example. Let's say I wanted to then also understand the correlation between anxiety, somebody's score on a test of math anxiety, and their score on a final exam. So I've got those two variables again. I've got my little box checked there. I hit OK, and now I see another correlation table. Here you can see the two variables, 112 people, and here you see the correlation actually is negative 0.432. That value would represent kind of more of a moderate correlation, but again, it's negative. What does that mean? It means as one goes up, the other goes down. So in this case, as somebody's score on a test of math anxiety goes up, meaning they have more anxiety about math, the score on their final exam goes down. So that's not too surprising why that's a negative correlation. Again, 0.432 is the correlation. Again, correlations run from negative 1.0 all the way through 1.0. The closer to 0 means the smaller or non-existent correlation between two variables or relationship between two variables. And again, looking at the significance value, we're looking at 0.05. This is well below 0.05. So we say the correlation of negative 0.432 between score on a test of math anxiety and a score on the final exam is statistically significant. All right, so I just did those two separate, but I want to show you something. If you have a bunch of variables and you're looking at a bunch of correlations, you can do a little shortcut. So let's just say I was interested in those two variables and those correlations. I could have done them. Let me just kind of quickly show you. I could have had all three of those variables put in here. So final exam, score on math anxiety, GPA, hit OK, and you just get a bigger table. So again, you see our numbers. Here's our negative 0.432 between math anxiety and final exam. Here's our 0.517 positive between GPA. And the other interesting thing is it also will give you now what's the correlation between math anxiety and GPA. And you see again, that's a negative correlation and it's below 0.05, meaning it's significant. So in this case, again, negative meaning as your score as your math anxiety increases, you generally have a lower GPA. So students who have more math anxiety tend to have a lower GPA. That's just what that is saying. So I could have done it separately, or in this case, I could have done it all together and saved myself a little bit of time. Again, this is just correlation, simply what is the relationship. So here, the important thing you're looking for is make sure you run the correlations that are specified for the assignment and make sure you're interpreting what is the actual R or Pearson correlation? Is it positive or negative? Based on the material in class, what is the strength? Is it small or weak? Is it moderate or is it large or strong? And then is it significant? Meaning is the significance value below 0.05? So that's the correlation between those variables. But let's say we want to actually look at linear regression. What is linear regression? How does it differ? It's very similar to correlation, but in linear regression, we're actually looking at direction of relationships. So instead of just saying, how do these two relate? We're actually saying, does one predict or influence the other? So let's say we're going to go back to our examples again. What if I wanted to look at, does a student's GPA predict their score on a final exam in statistics? So we're going to go back here, and instead of correlate, I'm going to go to regression. I'm going to go to linear. And my dependent variable is score on a final exam. So that's the outcome I'm interested in. GPA, in this case, I'm just looking at one variable, simple linear regression, one independent variable, one dependent variable. I'm going to hit OK. And here's what for our regression. So it tells you what variables are entered. So GPA is our predictor. Score on the final exam is our outcome. The key things to look at here, you'll notice the R, which is just that correlation again, is the same as before, 0.517. But what you'll notice here, R squared, which is just this value squared, is 0.267. And as indicated in your reading, this simply refers to what percent of the variability in the outcome can be explained by the independent variable. So in this case, of all the variability in the outcome of the final exam score, if we turn this into a percent, about 26.7 or almost 27% can be explained by GPA. So if I know somebody's GPA, it can explain about 27% of the variability in the outcome of the final exam. If I come down to this table where it says ANOVA, I'm simply focusing on this F and the significance value. This tells me, does the simple linear regression model with one independent variable and then one in the dependent variable score on final exam, is it significant? In this case, it is. So we say that this model of predicting score on the final exam from GPA is significant. And then if I come down here, it gives me my what we call our regression coefficients. In this case, there's only one variable. Constant simply means if the GPA was 0, what would the final exam score, what would that be? In this case, 15. We don't have anybody with a 0 GPA, so it's kind of, it doesn't really matter. So what happens here is this tells us, this 17.257 is telling me for every 1 unit increase in grade point average, so for example, from a 3.0 to a 4.0, we would expect the final exam score to increase by 17.25. Or if the difference between 2.5 and 3.5 GPA is likely to be about we would predict, not exact, we would predict there would be a 17-point difference in the final exam score. When it says standardized, this is just in standard deviation units. So what this is saying is for every 1 standard deviation unit increase in GPA, there would be about a 0.5 standard deviation increase in the final exam. And again, here's where we're looking at, we get a t-statistic and a significant value. It's saying, is this predictor, this single predictor of simple linear regression of GPA, is it a significant predictor of a final exam score? And again, this is below our cutoff of 0.05. So we conclude that there is a significant, this is a significant predictor, and that this is a significant regression coefficient value. So again, correlation is simply looking at relationships, not directionality. Is it positive? Is it negative? What's the strength of the relationship? Again, positive correlation means as one goes up, the other goes up. Negative means as one goes up, the other goes down, or vice versa. And then simple linear regression involves one predictor. We're looking at actual direction of prediction. In this case, we want to know, does a student's GPA help us predict their score on a final exam? We interpret this R-squared value. What percent of the variability in the outcome can be explained by our predictor? In this case, almost 27%. The model as a whole is, right, as we see here, is significant. And then when we do simple linear regression, we're always going to have one, which is a constant. And we're going to have the actual predictor, or what we call the independent variable. And you can see here again, here are the coefficient. This is the coefficient, unstandardized. This is standardized. And then this is significant. This is telling us GPA is a significant predictor. And that's how you do correlation in simple linear regression.